All right. So if you are doing this by hand, and I'll show you, and we'll derive what the calculator does too. But all you have here is you have these two exponents that are divided. Anytime you divide two numbers, two exponents with the same base, what do you do with their powers? We take our common base, 9. This is 9 to the first, and this is 9 to the minus 4/5. So when you divide exponents with the same base, you subtract their powers. So basically what you're saying is we take that common base 9, and we get 1 minus a negative 4/5. So minus a minus becomes a plus. And really, since we're combining 1 and 4/5, let's turn 1 into the same fraction. 1 is how many fifths? 5. So if we think of this as 5/5 plus 4/5, we get 9 to the 9/5. And so this is the answer. They're asking you to put it into the form, to enter it online, to put it into this form. Okay, now, here's the way that your calculator simplifies this or works with it. And if we were doing more by hand, I would go into this in more detail. But what do you notice about 9? 9 is a perfect power, right? Can you express that as an exponent with a smaller base than 9? 9 is just 3 squared. So really, if you think of this as 3 squared to the 9/5, what do you do when you take a power to a power? What do you do with the powers? Multiply them. So 2 times 9 over 5 gives you 18 over 5. And so now it's just a matter of simplifying. So anytime you simplify, you can't have a numerator greater than the denominator of this rational power. So what you would need to do is you'd need to take out groups of 5. So how many groups of 5 can you take out of 18? 3. So that really kind of, when you simplify that, it's like saying 3 to the 5/5, 3 to the 5/5, 3 to the 5/5. And then how many would be left in this last base, 3? How many fifths? You have 5, 10, 15. How many are left inside? 3. Okay. And so when you look to simplify that, you wind up removing these 3. So 3 times 3 times 3. And then you have this 3 to the 3/5 left.